The factor theorem. If f of c equals 0, then x minus c is a factor of f. If x minus c is a factor of f, then f of c equals 0. We can determine a factor by showing we get a remainder of 0 when we divide. So for example, let's determine whether x minus 2 is a factor of f of x equals 4x to the fourth minus 15x squared minus 4 by evaluating f of 2. Well, if f of 2 is 0, then x minus 2 is a factor by the factor theorem. So let's evaluate f of 2. We take 4 times 2 to the fourth minus 15 times 2 squared minus 4. Well, let's see, 2 to the fourth is 16. 16 times 4 is 64 minus 4 times 15. So we have 64 minus 60. So that's 4 minus 4. 4 minus 4 is 0. Let's check that with synthetic division. And remember, for every missing degree of 0 in the dividend, we put a 0 placeholder for that term. So we are going to divide by 2. The leading coefficient is 4. I don't have a cube term, so I put a 0 for the cube term. I do have a squared term, and its coefficient is negative 15. I don't have a linear term. I don't have x to the first degree, so I put a 0 as a placeholder, and then negative 4 is the constant. So I've represented every term from the highest degree down to the constant, and if I needed to, I put zeros as placeholders. So I bring down the 4, put my evaluation bar across there. 4 times 2 is 8, 0 plus 8 is 8. 8 times 2 is 16, negative 15 plus 16 is 1. 1 times 2 is 2, 0 plus 2 is 2. 2 times 2 is 4, negative 4 plus positive 4 is 0. So I do have a remainder of 0. So 4x to the fourth minus 15x squared minus 4 equals the divisor x minus 2 times, I'm taking the depressed polynomial and popping back in the degrees, starting with x cubed, which is 1 degree less than x to the fourth. I get 4x cubed plus 8x squared plus x plus 2 plus my 0 remainder. So the remainder is 0. We know that x minus 2 is a factor of f of x, and 2 is a 0 of f.